All right, welcome back, and now let's put some of these into action here. So, some of the examples, want to find the unknowns. So, in the first one, I want to find x. Well, how do you find x? Note that this goes to center to a point. This line here is not a tangent, so we can't use the two tangents being equal. However, we do know that a tangent and a radius are always perpendicular, and our buddy Pythagorean theorem comes back into play. All right, so we have a Pythagorean theorem question where 5 is the hypotenuse because it's across from the right angle. So we end up with x squared plus 3 squared equals 5 squared. So x squared equals 25 minus 9, which is 16. So therefore, x will equal 4. All right, so Pythagorean theorem is going to play a role for us in some of this homework. Moving along to B part. Here we go, we have a common point for the two tangents. I'll just label them so I can reference them. I'll put the center of the circle. So if we have two tangents going passing through a common point, we know that AC has to equal AB. So therefore, the length x will be 9. We know that triangle AOB, so triangle AOB is similar, and this is the symbol we use for similar, to AOC. So if they're similar, that means they share or have the same angles. So therefore, y would have to be 35 degrees. And finally, Z is the sum of the angles inside the triangle here. So 180 degrees in the triangle. We know the angle at B is 90 degrees, and we know y is 35. So 90 take away 35, 55 degrees. So there we are. That's B finished. Moving along here. This one's a bit of a trickier one, just because it doesn't pass through the center of the circle. The center's here. The two tangents, though, are sharing the same point. So what does that mean? So if it's tangent at points B and C, we know that AB equals AC. So we know those are true. So how are we going to find angle x? Well, triangle ABC is isosceles. If it has two sides the same length, that means that the triangle is isosceles. If the triangle is isosceles, that means that the bottom angles will have equal magnitude. So they're both 40 degrees. There you go. D, on to D. So with D here, we have, that is our only piece of information. So we have two circles that are tangent to each other with a tangent drawn through it. So AB and C. So how do we find x? Well, I know that, oh, that's excellent labeling. You must be pretty impressed with me. Math teacher, not English. Silly alphabet. B, C, D, there we go. Now you're thinking, well, probably not thinking any better, but still. So if we look at the first circle, ignore the second one, we know that AB has to equal AC from the property that two tangents that share a common exterior point are equal in length. So therefore, AC has to be 12. Well, AC is also sharing a common point with AD, and it's also tangent. Now that we know AC is equal to 12, we also see that AC and AD are tangents that share the common point, which means that AD has to equal AC in length. And if that's the case, then our value of x would have to be 12. So they, in fact, all end up being equal length. All right. All right, 3 more quick examples here. And this is where it gets a little bit, and I'm matching up. This is what how the book does it, and I'll talk about that here immediately. They place the angle outside the circle, and it's relatively confusing the first time you look at it, and it's just the way the textbook has done it. I'm not a big fan of the notation. That 260 degrees, they're referring to the arc length, and that 260 actually is this length right here. All right, so it's going to be that that angle inside or outside the radiuses. So knowing that, if we now know that, we know that a circle has 360 degrees, and if 260 are on that side, that means we have an even 100 degrees on the inside. We know that the radius and the tangents make 90s, so that gives us 180 plus 100. And what we have is, here's our quadrilateral. And this is in the opening statement, the learning goal. I talked about finding the angles of quadrilaterals, and that's what we have here. So x is equal to, there's 360 degrees in a four-sided shape. I know that I have two 90s, and I know I have 100 in there. So that gives me 180 minus 100, so x is going to be 80 degrees. Okay, so that's how that particular question works. Similarly, and it's more just showing you what how the textbook represents it. Here, that's 60 degrees. That's the arc length, or the subtended angle of the arc. So there's the 60 degrees. That's where it should be placed, and that's where I'll place it on a test for you. But I just want you, when you do the homework, you don't get frustrated. So there we go. So if we want to find x again, x is 360 degrees in a quadrilateral, minus 90, minus 90, minus 60. 180 take away 60 is 120, even though it doesn't look that way. That's our value of x. And then the last one, it's going the opposite direction. It wants us to find that external angle. So this one right here. So it's a funny looking quadrilateral. Nonetheless, we know that this one makes a 90 degree there. So we have that. We know that the subtended angle, or the angle inside, if I construct this radius, will give me 50 degrees. All right. So as we work our way through, and when I just realized I made these numbers up in my head, and I know the triangle this question falls apart on me. And this is what happens when you make stuff up in your head here, that the internal angles don't equal 360. So the question's kind of moot here. So I'm going to leave this example. Let's cross this one out. For now, when you come across a question similar to that with numbers that actually work, I'll help you out in class with that. But you're going to see a question like that, but numbers will work out for you. And the final set of examples I want to run through is using our buddy Pythagorean theorem again. So I want to know if the lines are tangent. So the question is this line here, is that line in fact tangent? So how do we know it's tangent? Well, if it's tangent, this will be a right angle, and that means Pythagorean theorem would work. So if we go through and perform Pythagorean theorem, we're going to treat it as a left side, right side proof. So that means that 6 squared plus 12 squared would have to be the same as the right side, which would be 13.4 squared. So 36 plus 144 is equal to, so that's going to give us 50, so it's 180. And when we figure out or expand the 13.4 squared, we find that it gives us 179.6, and based on the fact that I did the example, I'm going to say that's close enough to justify it, because that was my intent. All right, same thing here. Is this a right angle? All right, notice that this is not a tangent, so just be careful, they're not equal lengths. All right, so same thing. Does 9 squared plus 15 squared, is it the same as 18 squared? So, pulling out the calculator here to do the calculations, 18 squared is probably not that. So, 18 times the 18, 324. And on the other one, 9 squared, which is 81, plus 15 squared, 1440. Just double check that. No, not even close. Didn't do it the right order of operations. 306. Either way. Either way, left side not equal to right side. So there we are. There's the assigned homework that you're going to work in class on tomorrow. If you have any questions, let me know. But we're basically using those particular properties that we talked about at the start. So we'll clear up any problems that you run across as they arise. Good luck.